So one of the things I've been wanting to try for a while is laser welding plastic. So the idea being we 3D print some parts out and set two pieces next to each other, hit them with a laser and see if they'll melt together. This process is commonly used for metal parts. You don't really have any consumables, and it's also a very precise welding method. I'm going to jog the machine and basically just click on the middle of the antenna, and that should move the laser to the middle of the antenna. Then I'll just need to line up the part. If I move the laser too close, it's going to be cutting or engraving this plastic. I'm going to leave it pretty far separated from the part just so that I'm not dumping too much energy in a small area and lighting it on fire. Basically, I just want to be zoomed out and putting a beam of heat down on there. So it's going to be spreading that laser energy over a wider area. That should mean that it's not going to be cutting it. It should just be heating it up and melting it. So we'll see if this works. Alright, so we'll stop it there and check out what we did. So it actually looks like I melted it together. That's exactly what I was going for. I think I might move the beam up a little bit more just to make it a little more defocused. The beam's a little too concentrated and it's burning the plastic. Alright, it looks like we're still lined up pretty well. And I'm going to change it so instead of doing 4 passes, I'm just going to do 2. Now that's bright, so you're going to want to wear your safety glasses. Okay, let me line this up a little bit. Might be a little too defocused now. I'm going to zoom it in just a little bit. We'll zoom it in a little bit more. I just want to make sure everything's nice and melty. Now since this is all digitally manufactured, everything should line up just right. It's kind of the cool thing about doing this all with a computer. Alright, and our laser welding is complete. Now I sprinkled some sugar around here just to see how the sugar would affect the bonding. I was thinking that sugar melts pretty easily, so it might improve the laser welded bond. Also I tried feeding some... That fell apart. Also, I tried feeding some plastic into the joints over here. I don't think it really did anything though. So let's see how well our laser welds will hold together. This one fell apart right away, which is kind of unfortunate. It looks like the laser wasn't aligned properly and it was just melting part of this ear without melting the thing that it's supposed to stick to. Yeah, this didn't work out super well. I can just break through most of this. I mean, this is stuck in there decently, but I mean... Now this joint that I went over several times is holding together pretty well. So maybe I just needed to go over these joints a few more times. But you can see... that was pretty hard to break apart. I'm not super impressed here. I think the gap between the parts is too big. So you can see, even if the laser is melting that plastic, these pieces won't stick together unless they're butted up against each other. The laser kind of polished the edges of this part, so we still might be able to use laser post-processing of 3D printed parts to anneal them and improve interlayer bonding, and to modify the surface texture. But this welding, at least this first experiment, wasn't too much of a success. Let me know in the comments if you want to see more videos on laser post-processing of 3D printed parts. Usually when you're trying something complicated like this, it doesn't work on the first try, so I might need to make some changes to my process to get it to work properly.